Alright, so this is a homework problem from thermophysics. It's the thermophysics textbooks. I think I have it somewhere in a playlist I showed you. If not, it's Thermophysics by Blundell. I believe it's a second edition. Anyways, this is a homework problem I'm going to be going over. Number one, because some of you might be curious on how to do it, and number two, it's a homework problem that was assigned to me for my thermophysics class. So it's good practice for me, and if people get benefit out of it, then that's also a good thing. So we're going to solve this problem. Question, or part A of this question, says how many water molecules are there in the body? Assume that you're nearly all water. I'm just going to assume you're completely water. Now, in the book, we can find this equation, which is that the molar mass, which from here on I'm going to denote with a big M, little m, is equal to little m times Na. Now little m, that's the mass of one molecule or one atom. Now Na, you might have seen that, that's Avogadro's number. That's a constant, which is 6.022 times 10 to the 23rd. Okay, so the first thing I'm going to do is I'm going to solve for the mass of one molecule, and that's simple enough. It's going to be big M, little m, divided by Na is equal to the mass of one molecule. Okay, so if we know the molar mass of water, which we do, it's like 18, and we have this constant, we can find how much one molecule of water weighs. And if you plug those in, and the molar mass for water is also found in the book, but it's, I think, like 18 grams or something. You get 2.989 times 10 to the 23rd grams. So again, this is the mass of one molecule of H2O. Now, this is where you got to estimate a little bit and find the average mass of a person. So I just Googled the average mass of an American, and I got 88.8 times 10 to the 3rd grams. I just Googled that. So then what we want to do is we want to take your average mass, so I'm going to call this Ma, and we're going to divide it by the mass of one molecule. So we're assuming all this weight is the weight of a molecule, or the weight of water. There's nothing else in you. So then what we'll say is the average mass of all these people divided by the mass of one molecule will tell you how many molecules you have. And should you plug this in, you'll get 2.97085 times 10 to the 27 H2O molecules. Okay. That's a lot. And again, it's not actually that number because we're assuming that you're completely made out of water, which obviously is not the case, but it makes the problem a little bit easier, I guess. And then part B says, how many drops of water are there in all the oceans world? And then it tells us the world's oceans about 10 to the 21st kilograms. Again, I utilized Google, And I found that the mass of one drop of water is about 0.05 grams. Okay? So, what we're going to do is to find how many drops there is. We will say the mass of the ocean. Mass of the oceans. Let's put that a little. Divided by the mass of one drop. And you're obviously going to want to convert so you get the right units. But if you do that, you will get 2 times 10 to the 25th drops. So that's how many drops of water there are in our oceans. And then part C says, it's just comparison, which one of these numbers is larger? And we can obviously see that this number is larger. So how do we interpret that? That there's more water molecules in your body than there are drops of water in the ocean. So kind of crazy, right? So that was the problem. It was pretty straightforward. There wasn't a whole lot you needed to work through, so hopefully that makes sense though.